So we're going to talk about the LookAt command. So what is LookAt for? LookAt is for placing your camera relative to your scene. So here's a picture of a camera looking at a scene, and here's the projection onto the screen. And if this camera were to move around, we would use LookAt for that. So what does LookAt do? The main task of LookAt is to take your camera from some arbitrary location, looking at, say, this cube here in the top, and then transform the camera to be on the origin, looking down the negative z-axis at the object. And so the whole world has rotated and translated over. So the net effect of this is the same. You can think of it as moving the camera or rotating the object. So here's an example of that happening. So we'd like to get the camera looking on the negative z. So here we see the camera translating over to the origin and then rotating around to put the duck onto the negative z-axis. So are we moving the duck? Are we moving the camera? It's the same matrix operation. Here's the same thing. So if our camera is too high, we're going to rotate it down so that we're on the z-axis. If we're on the right-hand side, we're going to go around to the left so that we're on the axis. So how do we do this? There's a command, GLU LookAt. This page is in OpenGL 1.1. So this is the old fixed functionality way to write this, but you have exactly the same command available to you in WebGL. In your matrix libraries that are giving you something to do. Every graphic system is going to have something like this. So what are the parameters to this? We have an I location. So that's an XYZ 3 vector. That's where our camera is located. We have an at location. That's the center of the scene. In most representations, this is a point, but be careful, in some graphic systems, this is a direction vector as opposed to the point you're looking at. In WebGL, it's the point you're looking at, or at least in the system we're using for this class. And there's an up vector, which is telling us the rotation of this camera. So let's look at some examples. Here's our world, straight on. We have a teapot, and we'll look at our eye. In this case, you see this 14 here. We're on the positive z-axis looking at this thing. We're looking at the origin, and we've just set up to be y equals 1, and we're going to mostly keep it that way. So if we move our eye position a little bit, you see we've tilted this teapot a little bit. So here's some more extreme examples. If we put our y11, we're now up above the teapot. We're still looking at the origin, and we've still kept the up direction the same. If we switch our camera to be negative y, we're now below the teapot, looking at it from below. So the up, what does the up do? The up is essentially a rotation on what you're seeing. So let's go back to this initial position where we're looking at the teapot straight on. If we only change the up to, instead of being the y direction, we now change the up to be the vector 1, 1, 0. You see we've now, the up direction on this teapot is what used to be the 1, 1 direction, the xy 1, 1 direction. So what does this produce? This LookAt command produces a matrix. In OpenGL 1.1, we had a model view matrix. We now have a viewing matrix, which you're going to pass into your GLSL code. So the same way we pass a model matrix, we're going to pass a view matrix. And this view matrix is just going to be another uniform that you pass across, and the LookAt command is going to create that matrix for us. So what does this matrix look like? This matrix can be built by the commands here. We see this little figure. We have the eye at some position. We can calculate the in direction is the direction you're looking at in reverse. And then we have these orthogonal vectors v and u. We write all that stuff into this matrix. That's the matrix M. So what does LookAt? It's matrix M, a pin on a translate matrix to get our eye at the origin. In the next video, I'm going to show some examples of what does this do. I'm going to run some little screen capture example programs that show how does this work and what do we expect it to do.